Good morning, students. Chapter 9, Applications of Integration. So, in this chapter, first we are going to see two theorems of integral calculus. One is first fundamental theorem and the second one is a second fundamental theorem. So, using this, we are going to evaluate some definite integrals. Okay, we'll see the first fundamental theorem. If f of x be a continuous function defined on the closed interval a comma b and f of x is equal to integral a to x f of x du, f of u into du, that is your a less than x less than b, if it's so, then the differentiation of f of x is equal to small f of x. Okay, so we can say in other words, your capital F of x is an antiderivative of small f of x. Okay, so see that small f of x is a continuous function defined in the closed interval a comma b, and you can write like this: f of x is equal to integral a to x f of u du, means your capital F of x is called the antiderivative of small f of x. Okay, that means your capital F dash of x is equal to small f of x. So that's why your capital F of x is called the antiderivative of small f of x. And come to the second fundamental theorem. So you see that f of x is, if f of x be the continuous function defined on the closed interval a comma b and your capital F of x is an antiderivative of f of x. That means what's the meaning of this? From the first fundamental theorem, if you differentiate capital F of x, you will get the answer as small f of x. Otherwise, your capital F of x is equal to integral a to b small f of x dx. Okay, if it's so, a small f of x is a continuous function on the closed interval a comma b and capital F of x is the antiderivative of small f of x. If these two things happen, how to evaluate integral a to b f of x dx? So what is integral a to b f of x dx? The integration of small f of x with respect to the variable x is capital F of x. Okay, and you have to apply the limits. So it is from a to b. How to apply the limit? B is called the upper limit and a is called the lower limit. So your answer is f of b minus f of a. You see this example. You have to evaluate integral 3 to 4 x dx. So first what you have to do now, you have to integrate. What is the integration of x dx? So you know that you have studied in 11th standard, integral x power n dx is equal to x power n plus 1 divided by n plus 1. So x power is 1. So using that formula, it is x power 2 divided by 2. So we have completed capital F of x. Okay, and you have to apply the limits. What is the limits? 3 to 4. 3 is the lower limit and 4 is the upper limit. Here what is here? F of b. That means what? In the place of x, first you have to apply the upper limit. Here what is your upper limit? 4. Wherever you are having x, you have to substitute the upper limit. So it is 4 squared is 16. 16 by 2. In between what you are having? It is minus. Then you have to apply the lower limit. So that means what? Wherever you are having x, you have to substitute 3. So it is 3 squared is 9 by 2. So if you simplify, the answer is 7 by 2. So this is called the definite integral, because this definite integral is unique. So usually in 11th standard, here no limits is given in 11th standard. So after integrating, we will write plus c. Here, if the limits are given, you need not write plus c. It is not necessary to write plus c. You will get the definite values. So if the limits are there, this is called the definite integral. Definite integral is unique for each problem. Okay, so we'll go to properties of definite integrals. So first property, integral a to b f of x dx is equal to integral a to b f of u into du. So you see that in the place of x, here you can change the variable as u. So f of u into du. Okay, next one, property 2, integral a to b f of x dx is equal to minus integral b to a f of x dx. Here what is written? So if you interchange the limits in integration, you have to write minus in the front. And the third property, integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx. And the where c should be, c lies between a and b. If the value c lies between a and b, we can split this integral as integral a to c f of x dx plus integral c to b f of x dx. And the property 4, you see that integral a to b alpha f of x plus beta g of x into dx means you can write as two integrals. What is it? Alpha into integral a to b f of x dx plus beta into integral a to b g of x into dx. Okay, here alpha and beta are constants. So these are this four property, it is in definite integrals. Okay, so we'll come to exercise 9.3, first problem. In that 6 subdivisions are there. We'll see the first one, integral 3 to 4, what is that? Dx divided by x square minus 4. So this 4 can be written as 2 square. So in 11th standard we have studied some standard integrals. So using that, integral dx by x square minus a square can be written as, the formula is 1 by 2a log of x minus a divided by x plus a plus c. So here it is a indefinite integral, so we are adding c. But here you are having the limit, so it is the definite integral. So you just apply the formula for the integration. So according to the second fundamental theorem, first you have to integrate. So using that formula, in the place of a you are having 2. So wherever you are having a, you have to substitute 2. So it is 1 by 2 into 2 log of, in the place of x, you are having x. So in the place of a, you are having 2. So it is x minus 2 divided by x plus 2. After that, you have to apply the limits. So first, you have to integrate the given function. So the integration I have written, and you have to apply the limit 3 to 4. So how to apply the limit? F of x to the limit varies from a to b. F of x into, you see that according to the second fundamental theorem, so we have integrated, that is capital F of x, and you are going to apply the limit. The integral varies from a to b. So first is what? F of b minus f of a. So here first you have to apply the upper limit. Apply the upper limit means wherever you are having x, you have to substitute 4. So it is 1 by 4 log of 4 minus 2 is 2 divided by 4 plus 2 is 6. Next, in between what you have to write? So minus. Then you have to apply the lower limit. Lower limit is 3. So apply it. So it is 1 by 4 log of 3 minus 2 is 1 divided by 3 plus 2 is 5. So from these two, what is common? 1 by 4. So 1 by 4 can be taken out. So when you simplify this, log of 2 by 6 is 1 by 3, and here you are having 1 by 5. So from these two terms, 1 by 4 is taken out. So it is in the form of log a minus log b. After taking 1 by 4 out, it is in the form of log a minus log b. So using the logarithmic formula, it can be written as log of a by b. What is a? It is 1 by 3 divided by 1 by 5. So this 5 will go to the numerator. So your answer is 1 by 4 log of 5 by 3. Okay, coming to the second subdivision. So it is integral minus 1 to 1 dx divided by x squared plus 2x plus 5. So first it is a quadratic term. So we have to make it as a perfect square. So you know that. So it can be written as x plus 1 the whole square minus 1 plus 5. Okay, the shortcut you have to use. You have learned in 11th standard. Using that shortcut, it can be written as x plus 1 the whole square. So first you have to write the variable. What the sign here you are having, you have to write it. And you have to take the half of the coefficient of x. Here your coefficient of x is 2. So when it is divided by 2, it is 1. So you have to write x plus 1 the whole square minus 1. When you expand this, you will get this x squared plus 2x. And here you are having 5. So the plus 5 has to be written. See that it is x plus 1 the whole square. What is minus 1 plus 5? That is 4. This 4 can be written as 2 squared. So now it is in the form of integral dx by x squared plus a squared. So what is the formula for this? It is 1 by a tan inverse of x by a. So when you comparing this formula and the problem, in the place of x you are having x plus 1. In the place of a you are having 2. So it can be written as, you see that the whole term can be written as 1 by a. What is your a? A is 2. So 1 by 2 tan inverse of x. In the place of x you are having x plus 1. So it is x plus 1 divided by 2. And the limits varies from minus 1 to 1. Next we have to apply the limits. So first what you have to do? You have to apply the upper limit. So 1 by 2 is a constant. Tan inverse of, in the place of x what you have to write? 1. 1 plus 1 is 2. 2 by 2. So before applying the lower limit you have to write minus in between, because the formula is f of b minus f of a. So minus 1 by 2 tan inverse of, you are going to apply minus 1 in the place of x. So minus 1 plus 1 is 0. 0 by 2. So 2 by 2 is 1 and tan inverse of 0 by 2 is 0. Okay. So this 1 can be written as tan pi by 4, tan 45 degree, and 0 can be written as tan 0. So they are inverse functions. So tan inverse tan getting cancelled, you are having pi by 4 minus here 0. So when you multiply these two, your answer is pi by 8. Okay, we'll go to the third subdivision. So what is it? Integral 0 to 1 square root of 1 minus x divided by 1 plus x into dx. Okay, so see the solution. First step, so you have to multiply and divide by the conjugate of the denominator. In the denominator you are having 1 plus x, so you are multiplying and divided by 1 minus x. So within the square root. So see that 1 minus x into 1 minus x is 1 minus x the whole square. Here you are having 1 plus x into 1 minus x. So it is in the form of a plus b into a minus b. So the answer is a square minus b square. So it is written within the square root. So in the numerator, the square and the square root getting cancelled. So in the numerator you are having 1 minus x. In the denominator we can't cancel it because it is 1 minus x squared. So the square root of 1 minus x squared into dx. Okay, so how you can split? You can split using the property. We can split as two integral. The first one is integral 0 to 1 divided by square root of 1 minus x squared into dx. Separator we have written. Next one, what it is? Minus integral 0 to 1 x divided by square root of 1 minus x squared into dx. Okay, you see the property. We are having property 4. So using that property, you see that alpha into integral a to b alpha into f of x plus beta into g of x into dx can be written as alpha into integral a to b f of x dx plus beta into integral a to b g of x into dx. Using that property, we have split it into two integrals. Okay, see the first one. So you know the formula. It is in the form of integral dx divided by square root of 1 minus x squared. So the answer is sine inverse of x. After integrating, you have to apply the limits. So that's why I put the bracket and I have written the limits. Okay, here see that in the minus I have written plus, the minus I am giving to this x term. So, and after that I multiply and divided by 2. Okay, so why I have multiplied and divided by 2 now? You see, take the denominator. What is it? 1 minus x squared. If you differentiate 1 minus x squared alone, you see that the differentiation of 1 is 0 and the differentiation of x squared is minus 2x. So, in the numerator, I need minus 2x. So, that's why in between minus I apply to x and I need 2 also. So, I multiply and divided by 2. So, how this term looks like? You see the integration part. It is in the form of integral f dash of x by square root of f of x into dx. In 11th standard, we have studied this formula. So, integral f dash of x by square root of f of x dx, the answer is 2 into square root of f of x plus c. Okay, you see that 1 minus x squared, this is your f of x, it is written within the square root. So, in the denominator, it is a square root of f of x. In the numerator, you see, it is minus 2x, that is the differentiation of 1 minus x squared. So, it is in the form of, what is that? Integral f dash of x by square root of f of x into dx. So, the answer for the integration 2 into square root of f of x plus c. So, here this 1 by 2, it is written. So, according to the formula, 2 is written into square root of f of x, that is 1 minus x squared. After integrating this, you have to apply the limit. So, I have written 0 to 1. See now, first you have to apply the upper limit for the first term. So, in the place of x, the upper limit 1. So, it is applied. So, it is sine inverse of 1 minus sine inverse of the lower limit 0. This 2 and this 2 getting cancel. So, first you have to apply the upper limit. So, here you are having square root of 1 minus 1 squared, that is 1. Next, you have to apply the lower limit. So, before that you have to write minus, and if you apply the lower limit, 0 has to be substituted in the place of x. So, it is 1 minus 0. Okay, you see that sine inverse of 1, in the place of 1, it is sine 90 degree is written. In the place of 0, it is sine 0. And what is 1 minus 1? It is 0. So, this term is, we need not write. So, next one, minus square root of 1 minus 0 is 1. Okay, so see that sine inverse and sine getting cancelled. So, your answer is pi by 2. Okay, minus, what is sine inverse sine getting cancelled? It is 0. So, the last term is minus 1. So, pi by 2 minus 1 is the answer. And coming to the fourth subdivision, integral 0 to pi by 2 e power x into 1 plus sin x divided by 1 plus cos x into dx. Okay, see that here this term can be written as 1 divided by 1 plus cos x plus sin x divided by 1 plus cos x into dx. So, you have to keep the denominator. You should not be, here you are having plus, so it should not be separated. So, it can be written as 1 divided by 1 plus cos x plus sin x divided by 1 plus cos x into dx. So, you know the trigonometry identity. Okay, 1 plus cos x, that is, what is the identity? It is 1 plus cos 2x. it is equal to 2 cos squared x. So what is the formula? It is, see that the trigonometry identity is what? So we have learned 1 plus cos 2x, which is equal to 2 cos squared x. So but in our problem it is 1 plus cos x. So the angle is, it's a, here 2x you are having, here you are having x. So therefore it can be written as 2 cos squared x by 2, submultiple angle. So therefore in the place of 1 plus cos x, what the formula is written? 2 cos squared x by 2. In the same way, here in the numerator, sin x is there. Again we are using the trigonometry identity. What is it? Sin 2x can be written as, what is it? 2 sin x into cos x. But in our problem, we are having only sin x. So the angle has to be divided by 2. So sin x can be written as 2 sin x by 2 and cos x by 2. So the numerator, in the place of sin x, we have written 2 sin x by 2 cos x by 2 divided by 1 plus cos x is 2 cos squared x by 2 into dx. You see that 1 by 2. What is 1 by cos squared x by 2? It's a reciprocal of cos is secant. So here cos squared x by 2. So that's why it is secant squared x by 2. And this 2 and 2 getting cancelled. 1 cos x by 2 and the denominator 1 cos x by 2 is getting cancelled. And in the denominator you are having cos x by 2. So sin x by 2 divided by cos x by 2 is equal to tan x by 2. Okay, in 11th standard, using the exponential, we'll have the formula integral e power x into f of x plus f dash of x into dx. So the answer is e power x into f of x plus c. You see this function f of x and the differentiation of that function is added and it is multiplied with e power x, whose integration answer is e power x into f of x plus c. See now here e power x. So first I will take tan x by 2. So the differentiation of tan x by 2 is secant squared x by 2, and this x by 2 if you differentiate it is 1 by 2 into dx. So when you compare this term with the formula, in the place of f of x it is tan by x by 2 and your f dash of x is secant squared x by 2 into half into dx. Okay, so what's the answer for this integration? Answer is e power x into f of x. So first your answer is e power x into, what is your f of x? Tan x by 2. So after integrating, so you have to write the limits. So 0 to pi by 2. So the next step you have to apply the limits. So first which limit has to be applied? So upper limit. So in the place of x you have to substitute pi by 2. So e power pi by 2 tan of, in the place of x what you have to write? Pi by 2 divided by 2 minus, apply the lower limit. So e power 0 into tan of 0 by 2. So e power pi by 2 tan of, what is pi by 2 divided by 2 is pi by 4 minus e power 0 value is 1 but tan 0 is 0. So 1 into 0 is 0. Okay, see now tan pi by 4, tan 45 degree is 1. So 1 into e power pi by 2. So the answer is e power pi by 2. And coming to the problem number subdivision 5. Okay, first problem subdivision 5. So it is integral 0 to pi by 2 square root of cos theta sin cube theta into d theta. Take the term. So the sin cube theta is written as sin square theta into sin theta d theta, and sin square d theta can be written as 1 minus cos square theta. So from the identity sin square theta plus cos square theta is equal to 1. From that sin square theta can be written as 1 minus cos square theta. Here we are going to use the method of substitution. So for that, your cos theta can be written as t. Okay, so here you are having d theta is there. So you are going to differentiate with respect to theta. Okay, so the differentiation of cos theta is minus sin theta. Okay, and t you are going to differentiate with respect to theta, so it is dt by d theta. So in this term you are having sin theta into d theta. So this d theta I have taken to the left side and the minus I have brought to the right hand side. So therefore sin theta into d theta is equal to minus dt. Okay, so you see that the terms are changed in terms of t. So the limit also we have to change in terms of t. So first I have the limits are in theta. So 0 and pi by 2. You are going to change in terms of t. So you take the relation between theta and t. So what you are having? Cos theta is equal to t. Okay, theta what is now? It is 0. So in the place of theta, if you substitute 0, cos 0, what is cos 0? It is 1. So t is equal to 1. And next you see that in the place of theta, here you are having pi by 2. But what has to come? Cos pi by 2 is equal to t. What is cos pi by 2? It is 0. So what is the value of t now? It is 0. So you see that the limit how it is changed. First it is in terms of theta. So what is the theta limits? 0, pi by 2. Now if you substitute theta as 0, your cos 0 is 1. So the t will become 1. And if you substitute theta as pi by 2, cos pi by 2 is 0. So you take the first result, integral, write the integral symbol. So when theta is equal to 0, what is t? It is 1. So here in the lower limit you have to write 1. And when theta is equal to pi by 2, what is t? It is 0. So upper limit you have to write 0. And square root of what is it? Cos t. So it is cos t as t. So square root of t into 1 minus what is cos t is t, cos square t is t squared. And what is sin theta d theta? Here we have written minus t. So therefore this term is changed everything in terms of t now. Okay, and using the properties of integrals, see that here the limit is 1 to 0. Now I change the limit as 0 to 1. So upper limit and the lower limit is interchanged according to the property. You see that property 2. According to the property 2, here integral a to b, you see that integral a to b f of x dx is equal to minus integral b to a f of x into dx. If you want to change the limit, you have to write minus. You see that here I have changed the limit. Limit is 1 to 0. So now I have written what it is, 0 to 1. So I have to write minus. So here also you are having minus. So minus into minus will become plus. So that's why the terms are integral 0 to 1 root t into 1 minus t squared into dt. Okay, so you have to multiply root t with this term. So root t into 1 is root t minus, you see that, root t into t squared. So root t means t power half. T power half into t squared. What has to come? T power half into t squared. So the base are same. If you want to multiply, you have to add the power. So it is 2 plus 1 by 2. So that's why here I have written 2 plus 1 by 2. So when you take LCM, when you simplify, it is, what is it? 4 plus 1, that is t power 5 by 2 into dt. So now what you have to do, you have to integrate. So here you are having two terms, in between you are having minus, so you have to integrate separately. Go for the first term, t power half. It is in the form of x power n. So what is the integration of x power n? X power n plus 1 divided by n plus 1. So t power half plus 1. Half plus 1 is 3 by 2. So t power 3 by 2 divided by 3 by 2. And coming to the second term, it is also in the same form, integral x power n. So when you integrate, it is t power 5 by 2 plus 1. So it is 7 by 2 divided by 7 by 2. And you have to write the limits 0 to 1. So next step, you have to apply the limit. So while applying the limit, first you have to apply the upper limit. So here what is the variable? T is the variable. So wherever you are having t, you have to substitute the upper limit. So it is what it is, 1 to the power 3 by 2. So before that, the denominator 3 by 2 you are having, how it is changed? It is 2 by 3. So because 2 is in the denominator of the denominator, it will go to the numerator. So it is 2 by 3 t power 3 by 2. Here this can be written as 2 by 7 into t power 7 by 2. And you are going to apply the limit. So first you are going for the upper limit. So in the place of t, you have to substitute 1. 1 to the power anything is 1. So the first is 2 by 3 minus, and when you apply the upper limit here also it is 1. So 2 by 3 minus 2 by 7, this is the upper limit. Next, you have to apply the lower limit. Before that, you have to write minus. What is the lower limit? 0. So when you apply in the place of t as 0, so the first term is 0 and the second term also 0. So the lower limit is 0. And you have to take LCM. The LCM is 21. So therefore, the numerator for this is 14 minus 6. So the answer is 8 by 21. Okay, using the method of substitution, we evaluated the definite integral. And coming to the problem number, that is problem number 1, the sixth subdivision. Integral 0 to 1, 1 minus x squared divided by 1 plus x squared, the whole squared into dx. So here also we are going to do the method of substitution. So let x is equal to tan theta. So you have to substitute x is equal to tan theta. So here everything has to be converted in terms of theta. So here you are having dx. So differentiate with respect to x. So if you differentiate x with respect to x is 1. And here you are having tan theta. So the tan theta differentiation is secant square theta. And you are differentiating with respect to x. So therefore it is d theta by dx. So you have to substitute dx. So dx you have to take it to the left hand side. So dx is equal to what it is? Secant square theta into d theta. And your limits are in x. So it has to be changed into theta. So I put a box. So x limit is 0 and 1. Okay. See that in the place of x, what is your x value first? X value is 0. So what's the relation here? You are having x is equal to tan theta. What is your x value now? X value is 0. Okay. So here tan of which angle is 0? So tan 0. So if x is 0, your theta is 0. So that's why I have written when x 0, your theta is 0. And the next one you see that x is equal to tan theta. That is the relation you are having. See now here what is the x value? X value is 1. So 1 is equal to tan pi by 4. Tan 45 degree is 1. So in the place of theta here what you are having? Pi by 4. So therefore when x is 0, your theta is 0. When x is 1, your theta is equal to pi by 4. So here I have written the limits. The limits are changed in terms of theta. So you call the 1. So integral, in the place of 0, you are substituting 0. In the place of 1, you have to write pi by 4. So 1 minus, what has to come? In the place of x, what you have to write? Tan theta. So tan square theta divided by 1 plus tan square theta, the whole square, into dx. Dx has to be changed as secant square theta into d theta. So everything is written in terms of theta, and using the trigonometry identity, what is it? Secant square theta minus tan square theta is equal to 1. Otherwise 1 plus tan square theta is what? Secant square theta, the whole squared. So you see 1 secant square theta getting cancelled. So in the denominator you are having secant square theta. Okay, so it has to be splitted. So 1 is 1 by secant square theta minus tan square theta by secant square theta. You see that? 1 by secant square theta minus tan square theta by secant square theta into d theta. What is the reciprocal of secant theta? It is cos theta. So therefore here the first term can be written as cos square theta, because here you are having secant square theta, so the reciprocal is cos square theta. And tan square theta, how it will be written? Sin square theta by cos square theta into what is remaining? 1 by secant square theta. What is 1 by secant square theta? Cos square theta. So this cos square theta and this cos square theta getting cancelled. So what is here? Cos square theta minus sin square theta. You know very well, it is the trigonometry identity cos 2 theta. What is it? Cos 2 theta. Now you can integrate. So up to this we have used the method of substitution, and we have used the trigonometry identity. Now only we are going to integrate. So integral cos 2 theta. So the integration of cos 2 theta is sin 2 theta divided by 2. So it's a integration formula. Sin 2 theta divided by 2, because the coefficient of theta is 2, so it has to be written in the denominator. So you know the formula, and you have to write the limits 0 to pi by 4. So first you have to apply the upper limit. So here the variable is theta, so in the place of theta you have to apply pi by 4. So sin 2 pi by 4 divided by 2. And next, before applying the lower limit, you have to write minus. So minus, next you have to apply the lower limit. So in the place of theta you have to substitute 0. So 2 into 0 is 0. Sin 0 by 2. So when you simplify this, 2 and 4 getting cancelled. So the numerator you are having sin pi by 2. In the denominator you are having 2. Minus, what is sin 0? It is 0. 0 by 2. So what is 0 by 2? That is 0. What is sin pi by 2? Sin 90 degrees 1. So what is first term is 1 by 2 minus here 0 by 2 is 0. So the answer is 1 by 2. Okay, thank you students.